matrices. And by definition, a matrix is simply a group of items that are enclosed within curly brackets. Yes, Sarah, congratulations, you made it. That's good. So I'm saying a matrix is simply a group of items that are enclosed together within brackets. Now the brackets that we use are like these ones. These are the brackets that we use for matrices. If you use these others, that now becomes a set. Remember, by definition, the definition of a set and that of a matrix are similar because they are items that are enclosed within brackets. But the brackets in a set must be curly, they must have a curl. The other difference you notice is that in matrices, an item can appear more than once. For example, you can have 1, 2, 1, 1. Now, those 4 items in a matrix, they are okay. But if it is a set, they can only be 1, 2, because no item can appear more than once in a set. The other thing is when you're writing matrices, we always use capital letters. And when you're writing the elements, we use small letters. The horizontal arrangement of numbers, like if you have 1, 2, 3, then you have 4, 5, 6, 7, 8, 9. This horizontal arrangement, this one, is called a row. And when you're talking about rows, we use small I to represent the number of the row. The vertical arrangement, this one, is called a column. It's called a column, and we use small j to represent that. We use small j to represent that. Now, the number of rows and columns is known as order of the matrix. The number of rows and columns in a matrix is known as order. And when you're writing this, we write it as n by m, rather it's written n times m, but you read as n by m. So the sign times is not pronounced as times, but it's pronounced as by. The other thing is this order is usually written like somewhere here. Like now, this one is a 3 by 3. That means the matrix has 3 rows and 3 columns. The other thing that you need to note is the position of an element. The position of an element is shown using the intersection at the intersection of the row and the column at which the element is found. For example, this element here is at the intersection of row 2, column 2. So it is 2, 2. This is an element that is at the intersection of row 3, column 1. This is an element that is at row 3, column 3. And having said that, together with what I had said here with the order, we should always remember that when we are describing the matrix, the number of rows is always stated first. We always state the rows first, then it is followed by columns. The other thing is that these items here that you can find there, we call them the major diagonal elements. And after these ones, they are called minor diagonal elements. We will be coming across them as we do the operations. From there now, we need to look at the types of matrices. We have various types. Number one is what we call zero matrix. Now, a zero matrix is a matrix that has no elements inside it. In most cases, it is usually a result matrix. When you have subtracted, or maybe you have added and they have become zero. So it is empty. The other one is what we call single-tone matrices. Now, a single-tone is a matrix that has only one element. In most cases, we also call it the scalar matrix. It's called the scalar matrix, it has just one item. The other one is what we call equal matrices. Now, equal matrices is a matrix where we have the same number of rows and the same number of columns, the same number of rows and the number of columns. The other one is what we call identity matrix. Now, identity matrix is a matrix whose major diagonal elements are ones and the others are zeros. And I think you can see that clearly in the illustration that I've given you. Now, this identity matrix I is used as numeral 1 in the operations. And as we go by and by, you see how that comes in. The other one that you need to note is what we call row vector matrix. Row vector matrix. Now, a row vector matrix is a matrix that has only one row but more than one columns. One row but more than one columns. Like you can have 8, 9, 10. Now that is a 1 by 3. It has one row and 3 columns. The other one is called column vector matrix. Column vector matrix. Now in column vector matrix, we have just one column. Like you can have 7, 6, 5, 8, and more than one rows. So this one is a 4 by 1. It's a 4 by 1 matrix. The other one that we have is called transposed matrix. Now, a transposed matrix is a matrix whose rows and columns have been interchanged. Whose rows and columns have been interchanged. Like now, this one, or even this one, if you are to transpose this, instead of now being like this, it will be like this: 8, 9, 10. So that now you tell us that 3 by what? By 1. If you are told to transpose this, it will now be 7, 6, 5, 8. So that is now 1 by what? By 4. And the same case would happen here. It will now be 1, 2, 3, 4, 5, 6, 7, 8, 9. That is what we call transposed matrix. Now from there, the next bit that we need to cover is called the operations of matrices. Now in the operations, we have the 4 operations. We have the plus, we have the minus, we have the multiplication, and we have the division. Those are the 4 signs, the 4 mathematical signs, and they're the ones that define what we are calling the operations of matrices. Now in this case, anytime you are performing any operation, there are some steps that you need to follow. And these steps, number 1, you need to check the order of the matrices that are involved in your operation. You need to know what is the order. Number 2, you must be able to know has the rule that guides that operation been satisfied. The rule, has it been satisfied? After you confirm that the rule has been satisfied, you need to know the order of the result. What kind of a matrix will you get after you perform the operation? And then lastly, the next thing is you perform the operation. You perform the operation, and you get your result. And after you get your result, if there is any need, now you interpret the matrix. If there is any need, you interpret the matrix. So that is the order or the procedure that we are supposed to follow anytime we are dealing with the matrices. So having said that, we can now go to the notes and write, or rather to the book. So I hope you have written now the topic is matrices. You have written that it is matrices. Addition and subtraction. Subtraction of matrices. Addition and subtraction of matrices. Addition and subtraction of matrices. So as you saw in the notes, you can only add matrices or subtract if they are the same order. You can only add or subtract if they are the same order. So if you are told this is 3, this is -4, this is 6, this is 7, this is -5, this is -10, this is 9, this is 12, this is 18. If you are told to add -1, this is 8, -2, this is 2, this is 10, this is 6, this is -4, this is -3, this is -4. If you are given a matrix like that, you can only add matrices if they are the same order. So the first thing, as we have said, you check the order. These are 3 by what? 3, and these are 3 by 3. So that's the first thing. You check the order of the matrices. The second thing, to Kasema, you check whether the rule has been satisfied. And I've said the rule is you can only add matrices if they are the same order. So are these of the same order? So if yes, then you seek to know the result. You get a matrix that is of the same order as the ones that you're dealing with. Now from there, you add or subtract corresponding elements. You add or subtract corresponding elements. So now this will be 3 plus -1. That gives us what? 2. -4 plus 8, that gives us 4. 6 plus -2, that gives us 4. 7 plus 2, that is 9. 5 minus 5 plus 10, that is 5. -10 plus 6, that is 4. 9 minus 4, that is 5. This is 9. And this is 14. Which is a 3 by 3. It's a 3 by 3. Minus?
Yes. Plus 6.
Oh, imebaki -4, sio? Imebaki -4. Good. So that one, I don't think I need to add you another example. See, it's pretty simple. That's all. That's all. Nice. So sasa tuangalie multiplication. Multiplication of matrices. The multiplication of matrices. So example 1. Example 1. 2, 4, 6, 9. You multiply by 1, 3, 5, 8. Solution. If you're told to multiply matrices, as usual, tumesema you check the order of the matrices. So this is a what? 2 by 2. And these are 2 by 2 also. 2 by 2, 2 by 2. The rule that guides operations of the multiplication of matrix is like this. That the columns in the first should be equal to the rows in the second. So is that the case? Now, kama zimefanana, the matrix that you will get, the result now, will have 2 rows and 2 columns. So you should have that in mind. If we are going to have 2 rows and 2 columns, this is how it will look like. We will have an element in row 1, column 1, an element in row 1, column 2, an element in row 2, column 1, an element in row 2, column 2. That's how it will look like. So if you're looking for C11, you multiply the elements in row 1 of the first matrix and column 1 of the second matrix. So this will be 2 times 1 plus 4 times 5. This is 2 plus 20. That gives us what? 22. When you go to C12, this you take the values in row 1, you multiply by the values in column 2. And that will be 2 times 3 plus 4 times 8. So this is 6 plus that 2, that is 38. Then we have C21. C21 is the values in the second row multiplied by the first column. So that is 9 times 1 plus 6 times 5. 9 plus 35, no, plus 30 is what? 39. And then C22 is values in the second row, second column. 9 times 3 plus 6 times 8. 48 plus 27 is 75. Is that so? So that gives you the answer as 22, 38, 39, and 75. That is the answer down there. Which is a 2 by what? By 2. Two by 2. Pick example 2. Example number 2. Now in example number 2, you have something like this. You're given two matrices like those ones, and you are told to multiply. So as usual, when you come to the solution, you first of all check the order of the matrix. The order is a 2 by 3. And this one is a 3 by 2. So you check whether the columns in the first are also the rows in the second. Is that so? Then we say the matrices are compatible. So we are going to get a matrix that has 2 rows and 2 columns. So it's a case of C11, C12, C21, C22. You have that in mind. Then C11. It is, you take now the first row multiplied by the first column. So this will be 3 times 1 plus 2 times 2 plus 5 times 3. Give me that answer. 22. C12. It is 3 times 6 plus 2 times 5 plus 5 times 4. That becomes 48. C21 is 8 times 1 plus 7 times 2 plus 6 times 3. 40. And C22, it is 8 times 6 plus 7 times 5 plus 6 times 4. One. Yes, get 105. 107. So therefore, we have 22, we have 48, we have 40, and we have 107. Example 3, which will be your assignment. Tasoma namna hii. 3, 2, 1, 6, 7, 8. You can copy that, which you shall do later as an assignment. Tumeelewa multiplication? Ama baji? Is that okay?
Yeah.
Sarah. Sarah. So if it's okay, we proceed to the next. Let's now look at division. Division stroke inversion of matrices. Division stroke inversion of matrices. Now we do not quite often divide matrices, but we inverse, then we multiply. Because we know so well in the rows of indices, if you are given A, you divide by B. It is the same thing as B inverse, you multiply by A. Now the inverse is the reciprocal of the matrix. The inverse is the reciprocal of the matrix. The procedures that are taken to get the reciprocal, they depend on the order of the matrix. They depend on the order of the matrix. So let's start with the inverse of a 2 by 2 matrix. Inverse of a 2 by 2 matrix. Inverse of a 2 by 2 matrix. So let's start with the matrix here. You are given a matrix 2, 4, 5, 6. You are given a matrix like that, and they want you to get the inverse. There are several steps that you take. The first step is to get the determinant. The determinant. These steps are well articulated in the notes. So you get the determinant. So determinant, why not A within 2 strokes. That matrix within 2 strokes. And what you do, you get the major diagonal elements, you multiply them. That is 2 times 6. Then you less the minor diagonal. The minor is 5 times 4. That is how you get the determinant. So what is the answer? Minus 8. Higher. The next thing you do is to get something we call new matrix. So new matrix is obtained by interchanging the positions of the major diagonal. So that now will be 6 here and 2 there. And then you change the signs of the minor. So this now will become -5 and this will become -4. And remember, because we have 4 signs, when we say you change, we rotate between plus, minus. So division and multiplication are not involved. So it's plus, minus. After that, the inverse of the matrix. So A inverse, it is 1 out of the determinant minus 8. You have 6 here, -5, -4, and 2. And if you want to open the brackets, then this will be 6 out of -8, -4 out of -8, -5 out of -8, 2 out of -8. That is how it will be if you are opening the brackets. You're opening the brackets, that is how it shall be. So we can have example 2. Example 2, where you are given matrix B as 8 minus 7, 2, 3. If you are given a matrix like that, and they want an inverse, Mesema, what you do, you begin by getting the determinant. The determinant is B stroke that way, that is 8 times 3. Then you minus 2 times minus 7. So that is 24 plus 14. That is what? 38. Then we have new matrix. New matrix. So the new matrix, tumesema you change positions of the major diagonal. So this becomes 3, this becomes 8. Then you change the signs of the minor diagonal. This becomes minus 2, this becomes 7. Therefore, the inverse of that is B inverse is 1 out of the determinant, so 1 out of 38. This is 3, this is minus 2. This is 7, this is 8. So, hiyo iko sawa. Let's now look at inverse of a 3 by 3 matrix. Inverse of a 3 by 3 matrix. Inverse of a 3 by 3 matrix. Inverse of a 3 by 3 matrix, which we are going to call A. If you are given a matrix like that, and they told you to look for the inverse, there are several steps that you take. And the first step is to create a matrix known as minus matrix. Is to create a matrix known as minus matrix. Minus matrix. This one, you will have to just admire what I'm doing without writing. So look here. Now this one is the one we are calling minus matrix M. And this matrix is created by deleting the values that are in row I and column J of the original matrix. In simple terms, you start here. When you stop here, you drop everything in that column and everything in that row. You are left with what? 6, 9, 5, 1. Unakuja hapa. You drop everything in this row and in this column. Unaachiwa 2, 9, 4, 1. You come here. Drop everything in the first row, that column. Unaachiwa 2, 6, 4, 5. You come here. You drop everything here and everything in the first column. So you are left with 7, 8, 5, 1. When you come here, you drop the second row, second column. You are left with 3, 8, 4, 1. Then when you come here, you drop the second row, third column. You have been left with 3, 7, 4, 5. When you come here, drop that row, the first column, you are left with 7, 8, 6, 9. Ukifika hapa, you drop the third row, second column, so that you are left with what? 3, 8, 2, 9. When you get here, you drop the third row, third column, to be left with what? 3, 7, 2, 6. Now, the first check of whether you have done it well is these values in the first row here. Can you see that? Alafu hizi ziko huku ndani, the alternate. Hii ukiruka moja unaipata. This one, you skip this one, you get it here. So that is how you can check whether you have done it right. Now, as you can see, I've put these numbers inside strokes, meaning they are determinants. So chukua calculator to face determinants. 6 times 1 minus 9 times 5. Minus 39. Kuja hapa. 2 times 1 minus 4 times 9. Minus 35. 34. Tuende kwa huyo mwingine, you say 2 times 5 minus 4 times 6. Minus 14. Kuja hapa 5 times 7. No, 7 times 1 minus 5 times 8. Minus 33. 3 times 1 minus 4 times 8. Minus 29. 3, 5 minus 4, 7. Minus 13. 7, 9 minus 6, 8. 15. 3, 9 to 8. 3, 6 to 7. 4. Good. Copy up to that point. That's how you create the minus matrix. Oh, you're through, right? The next step after the minus is called cofactor matrix. It's called cofactor matrix. And this is how the matrix is made. You just copy the minus matrix again, and then you sign it. There are rules that I have given you the notes of signing. But for now, I just want you to grab two things. Very simple. The first thing is, here you start with the positive sign. The second thing is you go alternating, plus, minus, whichever direction you take. So this becomes minus, this becomes plus, this becomes minus, plus, minus, plus, minus, plus. That's all. You start with positive, you go alternating. When you multiply these two sides, your answer, your final answer now for the cofactor, this times this, we are left with minus what? 39. We are left with minus 39. That other one becomes positive 34. This one remains minus 14. This becomes 33. This becomes minus 29. This becomes 13. This becomes 15. This becomes minus 11. And this becomes what? 4. So that's a hii inaitwa the minus, no, not the minus. Inaitwa cofactor matrix. So utacopy hivi cofactor matrix, copy this one, and then you copy this. Very fast. The next step, that was step number 2. The third step, anaitwa determinant. Let me write it here. Determinant. Now, determinant, a determinant, very simple like this. Unakuja hapa kwa cofactor. Unachukua the first row elements. Na unaenda kwa the original matrix, the first row elements, you multiply as you want. So that would be 3 times minus 39 plus 7 times 34 plus 8 times minus 14. Another check that you can use. You see, I have told you to use the first row. You can use any other row. You can also use a column. Mesema the answer is 9. You can use any other row or any other column, and the answer will be the same. Just take one other using a calculator and confirm whether it's the same. Bora, ile umechukua hapa, uchukue the same. Kama ni column kwanza, take the column kwanza. Column 3, that. You put in the calc, any other selection. Is it agreed? Umekubali, eh? Okay, patience. So you can take any other. So if they disagree, that tells you have done wrong. But if they agree, that is right. The next step now is called adjoint matrix. You prepare adjoint matrix. And these adjoint matrix, it is simply transposed cofactor. So this cofactor is going to transpose so that we have minus 39, we have 34, and minus 14. Then we have 3, minus 29, and 13. We have 15, minus 11, and 4. And the last step is inverse. Inverse. So inverse is simply 1 out of the determinant. That is A inverse. It is 1 out of the determinant. 9 multiplied by the cofactor matrix. Sorry, multiplied by the adjoint. Multiplied by the adjoint. That's all. So for your assignment, you can do this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can get the inverse of that matrix. You can still call it matrix A. We'll call it matrix A. Good. Now those are the operations. Those are bigger applications of matrices. Applications of matrices. Applications of matrices. There are several applications. So the first one is called solving simultaneous equations. Solving simultaneous equations. If you are told to solve simultaneous equations, there's a procedure that you follow. So I want us to use the question that is in your handouts. So start reading for us the first question under the application solving simultaneous equations.
Determines the production of concepts. The production requires machine and labor inputs as follows. Machine hours are used, tax at 1.232 labor hours. The available machine hours and labor hours are 100,000 and 80,000 land required. This matrix cell is to find the optimal number of cuts and both that should be produced by the utensils.
Thank you. That's good. So the first thing we will say, let C to be the optimal number of cups produced. C to be the optimal number of cups that have been produced. B to be the optimal number of balls produced. Optimal number of balls produced. Then equations. In the equations, cups, they require how many hours in the machine? So it is 4C, and balls require how many in the machine? 2. So 2B is equal to the machine hours certainly 100,000. 100,000. Then when we go to labor hours, cups they require. So 3C and we give it 2B should be equal to, is it 80? 80,000. 80,000. Then you create matrices. Matrices are created by, first of all, grouping the coefficients, the numbers together. So we have 4, we have 2, we have 3, and 2 here, that way. To multiply C and B there. And this is equal to 100,000, 80,000. That's how you group. In grouping that, or after grouping that, you say on solving. On solving. Now on solving, you bring this one or you leave this one on its own side. That is CB is left on its side here. To be equal to this other one, You bring it here as the first matrix, 4, 3, 2, 2, but it comes in as an inverse. Because it has changed the size, it comes in as an inverse. To come and multiply 100,000 here and 80,000 here. So, because there's an inverse, we have to get the determinant. The inverse of a 2 by 2. So the inverse will be 4 times 2 minus 3 times 2. We have 2. You also have to create what we call the new matrix. So the new matrix is 2 here, minus 3, minus 2, and 4. So you get the determinant, you get the new matrix. So with those two workings, you have what is required for you to get the inverse. So you then proceed and say CB is equal to, we know how to get the inverse. It is 1 out of the determinant, so 1 out of 2, multiplied by the new matrix, which is 2, and minus 3, then minus 2 and 4. Multiplied by 100,000 here, and 80,000. Now remember, this is a 2 by 2, and this is a 2 by what? By 1 matrix. So with that, then we are going to have a matrix that is 2 by 1. So this becomes 1 out of 2. 2 times 100,000 plus minus 2 times 80,000. Minus 3 times 100,000 plus 4 times 80,000. So this proceeds to become a half. This is 200, 160, so that gives us 40,000. This is 300, 20, that gives us what? 20,000. And this leaves us with 20,000 and some 10,000 here. So thus, my C will be 20,000 and my B will be 10,000. Second crisis. We shall do the other one that follows. Read for us that one.
Traders added to sell 2 grams of beer with money.
Sio hiyo mtajifanyia nataka ya 3.
Western Hotel has 3 departments, namely maintenance, laundry, and kitchen. These departments are the main operating department of the hotel. The location of service cost among the service department is as follows. Maintenance, 5%. Maintenance for laundry, 25%. Maintenance for kitchen, 20%. Laundry for maintenance, 5%. Laundry for laundry, 15%. Laundry in the kitchen, 10%. Kitchen maintenance, 10%. Kitchen in the laundry, 15%. Kitchen in the kitchen, 10%. The direct costs allocated for the operations of each of the service departments are shown below. The maintenance, 224,000. Laundry, 1 million. Kitchen, 140,000. Required. Direct the equation to the total operating cost of each service department. Write the equation in matrix form.
Thank you. So we are given that. So here we will be able to say there are 3 departments. The first department inaitwa maintenance. So we will say that M to be the total maintenance costs huyo mwingine anafuata ni laundry. So L to be the total laundry costs. Then kitchen to be the total kitchen costs, where we should remember that if we are looking for the total costs, we say direct costs plus indirect costs is equal to total costs. Is equal to total costs. Then let's go to maintenance. Maintenance umeambiwa wako na direct cost ya how much? Hapo chini. 224,000. Now plus ukifuata hizo percentages zimepeanwa hapo, nataka to interpret them in terms of the row. So what percent belongs to maintenance? Interpret row wise. 5. So that is 0.05 M. K iko na unafuata row. So 0.25 L na kitchen iko na so 0.1 K. Now hizi za kugaiwa hizi ndio zinaitwa indirect. Direct is the one that is already given without any share. Should be equal to M. Because you have said M is the total cost. So you seek to put like terms together. This M, when it comes to this side, we will be left with the minus. You see, this is 5, eh? So be left with minus 0.95 M plus 0.25 L plus 0.1 K should be equal to minus 224,000. That one you call it equation number 1. Call it equation number 1. Huyo mwingine ako na direct cost ya 1 million. Tukiinterpret hivyo tu venye tumefuata huyo mwingine, M iko na what percent? So 0.05 M. L 0.15 L and K 0.1 K. Now this should be equal to L. So putting items together, I will be left with 0.05 M here minus this L here and this one. This minus 0.85 L plus 0.1 K is equal to minus 1 million. And you call it Roman 2. Huyo mwingine hapo na 140,000 plus ukiinterpret hivyo 0.1 M plus 0.15 L plus 0.05 L. No, K. Now should be equal to K. So putting like terms together, I'm left with 0.1 M plus 0.15 L minus 0.95 K should be equal to minus 140,000. Sasa, we now, those are the equations. So maybe you should have said here, then equations, so that now we come here and say matrices. Matrices. So if you have to express them in matrix form, we have said we take the coefficients. So the first one I have minus 0.95, followed by 0.25, followed by 0.1. Then I have 0.05, followed by minus 0.85, followed by 0.1. Then I have 0.1. Then I have 0.15 and minus 0.95. Multiply by, this is M, this is L, and this is K. And then we have minus 224. We have minus 1 million. We have minus 140. Then on solving down there, on solving, we will have M, L, K on this side being equal to minus 0.95, 0.05, 0.10. I have 0.25 minus 0.85, 0.15, 0.1, 0.1 minus 0.95. Now this is coming in as inverse. Come and multiply 224,000, 1 million, and 140, and these are negatives. These are negatives. So the minus matrix M, now we can write together because we have an idea of how it looks like. Minus matrix M, tukifika hapa tunafunga hii na tunafunga hii. Tunaachiwa minus 0.85, 0.1, 0.15 and minus 0.95. Tukifika hapa tunafunga the first row, the second column, tunaachiwa 0.05, 0.1, 0.1 and minus 0.95. Ndio tunaachiwa. Tukifika hii ya mwisho tunafunga third column, first row, ndio tuachiwe 0.05 minus 0.85, 0.1 and 0.15. Haya, kuja kwa hii tunafunga second row, first column. Tunaachwa na 0.25 and 0.1. And then 0.15 and minus 0.95. Kuja hapa, tunafunga second row, second column. So I'm left with 0.95, 0.1, 0.1 and minus 0.95. Nikikuja hapa nifunge second row, third column. So I'm left with minus 0.95, 0.25, 0.1, and 0.15. Because I know I have done the right thing, and I also know they alternate. Here, you skip one, you get it here. So the other one, this one, I will be getting it here. So I'll just copy 0.25, 0.1, minus 0.95, 0.1, minus 0.95, and 0.25. And then I know here, kwanza hapa, itakuwa ya mwisho hapa. So I just copy, minus 0.85, 0.1, 0.05, 0.1, 0.05, and minus 0.85. Does not take a lot of time. Calculator. Kwanza hii minus ya kwanza. Tuanze na hii ya kwanza, minus 0.85 times minus 0.95 minus 0.15 times 0.1. I'm getting 0.7925. Kuja hapa chini, itasema 0.25 times minus 0.95 minus 0.15 times 0.1. Getting negative 0.2525. 0.25 times 0.1 minus 0.25 times 0.1 is 0.11. Kuje kwa ile ya pili niseme 0.05 times minus times minus 0.95 minus 0.1 times 0.1, getting negative 0.0575. Minus 0.95 times minus 0.95 minus 0.1 times 0.1, getting 0.8925. Minus 0.95 times 0.1 minus 0.05 times 0.1 minus 0.1. 0.05 times 0.15 minus 0.1 times minus 0.85, getting 0.0925. Minus 0.95 times 0.15 minus 0.1 times 0.25, getting negative 0.1675. Minus 0.95 times minus 0.85 minus 0.05 times 0.25, 0.975. Agree those values? Should be through. So if we are through, we have agreed with all that. Okay. So if we have agreed that was about the minus, for the cofactor, matrix C, you don't have to recopy again. You have to recopy because it was the first time you are seeing. I assume so. Now here, you just say what? Plus. So you can even put that sign here. So itakuwa positive, negative, positive, negative, positive, negative, positive, negative, positive. So straight on your cofactor, actually in most of the application cases, cofactor will just be moving the negative from the minus. In most. So now hii negative itaenda hapa inaenda, hapa inaenda na hapa inaenda. Yes. In most cases. Yeah. So we have 0.7925, 0.2525, 0.11. 0.0575, 0.8925, and 0.1. Then 0.0925, 0.1675, 0.795. That's the cofactor. Let's get the determinant. So the determinant, you take the first row and the first row of the matrices of the cofactor. So it is 0.95 minus 0.95 times 0.7925 plus 0.25 times 0.0575 plus 0.1 multiplied by 0.0925. So solve that and give me the answer. Minus 0.7. Give me your own text without rounding. 963. 963. Here. Is it confirmed? I disagree. It should be minus 0.95 times 0.7925 plus 0.25 times 0.0575 plus 0.1 times 0.0925 equals 72925 negative. Sasa tuko na all the ingredients that we required here. Remember tulianza hiyo sifani hapa eh? We have all the ingredients that we required. So now MLK. It is inverse. Inverse, it is 1 out of minus 0.72925. We need adjoint. Adjoint, tunajua vizuri, we transpose the cofactor. Eh? We transpose the cofactor so that we have 0.7925, 0.0575, 0.0925. 0.2525, 0.8925, 0.11, 0.1, 0.795. Now this one you multiply by minus 224,000 minus a million minus 140,000 so this one you have you can multiply straight, eh? So you multiply, I have 0.7925 plus, not plus, times minus 224,000 plus 0.2525 times minus 1 million plus 0.11 times minus 140,000 equals, divide by 0.72925. I'm getting 610. 791.9095. Then 0.0575 times 224, no, it's negative, eh? 224 exponential 3 plus 0.8925 multiplied by negative 1 exponential 6 plus 0.1 times minus 14 exponential 4 equals, divide by 0.72925. Getting 1,260,719.918. 0.0925 times minus 224 exponential 3 plus 0.1675 multiplied by minus 1 exponential 6 plus 0.795 times minus 14 exponential 4 divide by 0.72925 equals 410. 723.3459. And remember now, this is your M, this is L, and that is K.